start recording. Share my screen. Okay, so that's that. Close. Okay, so let's just go to the lecture. Two. All right, so we are still continuing with design patterns. We finished the part one of design patterns, and that was basically on behavioral design patterns, right? So we basically established that behavioral design patterns are basically for solving problems that have to do with how your classes behave, right? Or how they interact with each other, right? So if you look at all three behavioral design patterns, for example, the visitor pattern, you'll see that it's based on the visitor class, for example, visiting another class, right? Which is an operation, right? If you look at the command design pattern, it's the same idea. It's one class that that's issuing commands to another class or another set of classes in order to perform a specific action, right? If you look at the observer design pattern, it's the same idea where you have the subject which notifies its observers, and then the observers basically update their state based on the new state of the subject, right? So all of them have to do with performing an action, right? So now we are covering structural design patterns, and these design patterns are less concerned with how the objects act, but they are more concerned with how the objects are structured, right? Or the composition of objects, right? So for example, for some of the design patterns, you'll see that it's important to like have an inheritance hierarchy. For other design patterns, you'll see that it's important to have like some sort of composition that's going on in order to fulfill the goal of the design pattern, right? So there's three kinds of structural design patterns. The first kind is the adapter design pattern. The second kind is the proxy design pattern. And the third is the facade design pattern, right? So I think they are fairly simple compared to behavioral design patterns. So yeah, there's not a lot of code that's involved and so forth. Okay, so structural design patterns are concerned with how classes and objects are composed in order to form larger structures, right? So we want to be able to design a pattern in such a way that we can add as many objects as we want, while we are still able, to achieve the same convenience, right? Without having to add to the complexity of the program. So they describe ways to compose objects in order to realize new functionality, and they let you to use inheritance, for example, to compose interfaces or implementations. They allow you to compose objects to realize new functionality and change the composition of objects at runtime, right? So, which is impossible with static class composition. Okay, so let's look at the first design pattern, right? For structural design patterns. So that's the adapted design pattern. So the adapted design pattern is also known as a wrapper design pattern. You've probably seen this design pattern before in your life, especially in computer science 1, second semester, when we did when you had a lot of container classes and all of that stuff. So I'll try to relate this to some of the stuff you did in Comp Sci 1. But basically, it allows you to convert the interface of a class into another interface that the client expects, right? So that's the main idea behind the adaptive design pattern. You create a class that is a wrapper class, and it basically becomes the class that's between the main class, or rather the class in question, and the client class, right? So it allows you to use an existing class, but if, for example, the interface of the existing class is incompatible with the client, right? And then it also allows you to create a class that cooperates with unrelated or unseen classes. And you can also use it if you are using several existing classes, but it's not really practical to subclass each class in order to adapt its interface. So much of this is not going to make much sense until we actually look at the design pattern. So here's the design pattern. You can see it has a very simple structure. So the first part that I'm going to look at is the abstract adapter, right? So the abstract adapter has an operation which the client expects, right? Or which the client can use, right? And we have a concrete adapter. So the concrete adapter simply provides the implementation for that operation. So the most important thing about the concrete adapter is that it stores a reference to the adaptee, right? So what is the adaptee? The adaptee is the class that contains the actual functionality, right? So this is the class that actually does something, right? But this class has an operation that the client does not support, right? So the client program, for example, does not understand how to use this operation. And that is why we create an adapter, a wrapper, which contains the adaptee as an attribute, right? In the form of composition, for example, and it has an operation that the client can understand, and this operation basically delegates the task to the adaptee, right? So that's the whole idea. So you have this wrapper class that interacts with the client, and this wrapper class delegates the task to the adaptee, right? So the only reason the adaptee does not interact directly with the client is because the adaptee is not compatible with the client, right? So an example of this, right? So let's take it back to ComSci 1, right? So let's say, for example, you had your, let's say when you were doing linked lists, right? So you had a function, for example, that could move one element of the linked list at a time, right? So in order to move one element across, you had to, for example, move between pointers, right? So you had to redirect a pointer to point to another memory address and so forth, which means that your client or the main method, right, would have to know about pointers, right? If you implemented a linked list in that fashion, where you exposed the pointers to the main function, then it would be very difficult for anyone to use your class, right? But instead, you created a wrapper class, which is an iterator, right? And your iterator is the class that actually had to deal with the pointers without your main function knowing about it, right? So all your main function did was it created the iterator object. For example, it used it in a for loop or a while loop or wherever you wanted to use it. And an iterator was called a smart pointer, right? Because it had, you know, like functions like iterator.begin, iterator.end, and so forth. And it basically hid all of that complexity from the client, right? And you only had to deal with the iterator, which was much easier to use, right? So the iterator in this case is the adapter because it provides an interface that is easier for the client to use. And your class that contains pointers and everything, that's your adaptee because that contains all the functionality that your client, which is the main class, is not compatible to. So that's the example of a wrapper class or an adapter, right? So the abstract adapter defines the interface which the client must use, right? So the interface is domain specific, right? And then the concrete adapter implements the function, right? Which is provided by the abstract adapter, right? So it's this operation here. So the abstract adapter provides that, and the concrete adapter implements the same function, right? But the most important thing is that in implementing this function, the adapter, the concrete adapter, is actually implementing an adaptation of the adaptee's existing interface, right? So that it can be used by the client, right? So we want to define an existing interface which needs adapting, right? So, or rather, the adaptee has an existing interface that needs adapting. So the client needs to make sure of the adaptee's interface, or need to make use, of the adaptee's interface, but it is not directly compatible, right, with the client. So it works with the concrete adapter in order to use the adaptee's interface, right? So let's look at an example, right? So let's say you have an adaptee class that has a sort function, right? Which accepts an array list of integers and sorts them and returns a sorted array list, right? So this is the adaptee class, right? It has a sort function, and it takes an array list of ints and it sorts them, also returns an array list of ints, right? So let's say you have a client class, right? That needs to sort an array of integers, right? But the client class does not know anything about an array list, right? Let's say it only knows about arrays, right? So what we want is to use the adaptee's sort function, even if it takes array list as a parameter to sort our integers, right? So then that is where we use the adapter design pattern, right? So what we can do is we can wrap the adaptee class in an adapter class, right? And then the adapter can convert our array from the client to an array list so that we can use the sort method in the adaptee to sort the integers. So the adapter can then convert the array list back to an array after sorting and return the array to the client, right? So it's sort of like a middleman. And then the client can make use of the sorted array, which was really sorted by the adaptee, but we know that it was actually sorted by, so it was sorted by the adaptee, but to the client, it would seem like it was sorted by the adapter, right? So here's our adaptee class. And so this is the, so obviously it's incompatible with the client because it works with array lists and not arrays. So in this case, it's called a number sorter. And then we have our array list of integers, which is returned by this function. And it accepts an array list of integers. And then so it does the sorting here, and then it returns the array list, right? So what we do is we create our adapter class, or rather our adapter interface, which is also called sort, but returns an array of integers and accepts an array of integers. And then we have our concrete adapter class, which implements the interface. So here's our overridden function. And as you can see, it returns an integer array and accepts an integer array. And then so we convert the array to an array list in order for us to be able to use the number sorter, which is the adaptee, right? And then so we pass the array list that we created here to the sort function of the number sorter, right? And then we get our array list back. And then we create our array that we're going to return to the user. And then we add each element in the array list to the array, and then we return the array to the client, right? So it's fairly straightforward, right? And then here's the client class. So in the client class, we basically have the main function, and then we have our integers that we want to sort, and then we create our adapter, and then we tell our adapter to sort the array. Obviously, that will then be converted into an array list here, and then that will be passed to the adaptee, which will sort it, and then we'll convert it back to an array. Right, and then we obviously we then just print out the sorted numbers, right? So that's basically the logic behind the adapter design pattern, right? Do you have any questions regarding this design pattern? Is it straightforward? Is it not straightforward? Okay, I'm not getting a response from you guys. Okay, all right. So yeah, so if there's no questions, I'll move on to the next one. And that's the proxy design pattern. So proxy design pattern, the definition of the pattern is actually in the name, right? So if you think about a proxy, right? A proxy is usually like it's also referred to as an agent, right? Someone who performs something on your behalf, right? Or someone who stands in the gap for someone else, right? That's what a proxy is, right? So the proxy design pattern works in a similar way, right? It's also called a surrogate design pattern, and it basically provides a placeholder for an object to control access to the real object, right? So if you think about the proxy server at UJ, I don't know about now, but when I used to do my undergrad, I remember we couldn't access half of, like the websites on the internet. We didn't even have access to YouTube, right? So I don't know if that's still the same with the student Wi-Fi, but the reason for that is because when you try to connect to YouTube using the Wi-Fi at UJ, what would happen is the connection goes via a server. So before it actually gets to the YouTube servers, it goes via a server called the proxy server. And that server will actually check if you are supposed to be accessing that website, or if you are allowed to access that website. And then if the proxy server decides that you don't have the permissions to do so, it will then block your access, and your request will not even get to the YouTube servers, right? So that's what a proxy is, right? Basically there to control access, right? So in this case, you can use this design pattern to achieve something similar, right? So if you want something more versatile than a simpler pointer to an object, so you can also use the proxy design pattern for this. This is called the smart reference proxy. This is also similar to an iterator in a linked list, right? Because in that case, you also have a situation where you are accessing this class that you might assume is actually, has direct access to the data, but it also has to ask another object, right, which has direct access to the pointer to the data, right? That's called the smart reference proxy. You can also use this design pattern when you want to control access to an object, right? By limiting access to some or all of the attributes and methods of the original object, right? This is called the protection proxy. And then you also use the proxy design pattern when you want to create instances of expensive objects on demand, right? So expensive, obviously in programming, means that an object that requires a lot of resources in order to instantiate, right? So if you want to create objects like wrapper classes, for example, that contain other objects, but only when you need them, right? You can use this design pattern, and when you use it in that way, it's called a virtual proxy. You can also use this design pattern when you want to provide a local representation of a remote object, right? This is one of the most popular uses of the proxy design pattern. An example of this is, let's say you are playing a game, and then, for example, the game has to keep connecting online to update, let's say, like the characters, or or like to update patches or something like that. And then, so what you have is you have an offline representation of the game, where you don't have to connect to the internet to play the game, but eventually, every now and then, it has to connect to the internet, to the real object, in order to update itself, right? So that's also a proxy, right? So that's another use of a proxy. Okay, so this is the structure of the proxy design pattern. So you still have an interface. In this case, it's called an abstract subject, and then it provides an operation, right? So the reason it's called a subject is because the client thinks that it is using the actual subject, right? And then you have the real subject, right? Which is, so let's go back, for example, to our example of, like a proxy server and YouTube, right? So let's say the real subject is the YouTube server, right? And then the proxy subject is the UJ server, right? So both of them, as you can see, they implement abstract subject, right? Which means that the client does not know the difference between the YouTube server and the UJ server, right? Which was me in first year, right? When I tried to access YouTube, I did not understand why I could not access it, because I thought I was going directly to the YouTube server, right? Only to find out that there was actually a proxy server that was standing in the way, right? So this then obviously has to implement the operation provided by the abstract subject, and the real subject also had to provide an implementation for that operation, right? So the proxy subject contains obviously the original subject, or a reference to the original subject, because usually how this will work is the proxy class will manage the life cycle of the real class, right? Because depending on the setting or the scenario in which you are applying this design pattern, usually the client will not even know about the real subject, right? It will only know about the proxy subject. So the proxy subject will know about the original subject. So the abstract subject defines a common interface for both the real subject and the proxy subject, so that the proxy subject can be used anywhere that the real subject can, right? If they implement the same interface, it means that anywhere where you can use the real subject, you can also use the proxy subject. And the real subject defines the real object that the proxy subject represents. That is true. So the proxy subject maintains a reference that lets it access the real subject. It also provides an interface that is similar to the real subject, so that it can obviously replace the real subject wherever needed. And most importantly, it controls access to the real subject, right? And it can also be responsible for creating and deleting instances of the real subject, right? So managing the life cycle of the real subject. And it can have other responsibilities depending on the environment, right? So the client then gains access to the real subject via the proxy, right? So the client has to use the proxy subject to access the real subject in a capacity that the proxy subject allows, right? So in other implementations, some clients can have like full access to both the proxy subjects and the real subjects. Yeah, so it's really hard to justify why that would still constitute the proxy design pattern, but it is done like in other implementations. Okay, so let's look at an example, right? So let's say, for example, we have one class that stores secret information, right? Let's say as a string, right? And then this secret information can only be given to users who have the correct credentials, right? So they have to provide their credentials and they will access the information, right? So we can use this design pattern to define an interface called secret, right? Which defines a method to gain access to the secret, right? And then we can create a real secret to store the actual secret, and just implement an accessor method to get the secret. And then we can define a proxy secret to limit access to the real secret by implementing a different accessor inside of the proxy, which will first check if the user has the credentials that will allow them to access the secret, right? So, and then we have a client class which stores a reference to the proxy, and we'll call the get secret. And then for added security, we can even, only have the secret class stored inside of the proxy, right? Make it a private member attribute so that the client does not know anything about it, right? So when the client creates the proxy will instantiate the real secret. And then when they try to get the secret, then the proxy will delegate the task to the real secret and return that to the user only if they have the credentials. So let's look at the code. So we have an abstract subject interface. So obviously every subject has to have this function called get secret, because the secret should implement it as well as the proxy secret, right? So so here's the secret. This is what we're protecting. So here's the method that actually returns the secret. So there's nothing new here. So this is just an attribute. This should actually be private so that it's not accessible outside of this class. And then we can only access it using this mutate accessor method. So, and then we have the proxy secret. So the proxy secret then stores the real secret, right? And manages its life cycle, right? So, so here's the get secret of the proxy class. So it stores its own local secret variable for storing the secret, and it first wants a password from the client, right? So before it can return the secret, the client first has to provide the password, right? So just show an input dialog. Don't worry what a J option pane is. This is a UI control from the Swing Java user interface library, right? So you guys are using JavaFX, so you could probably use something else other than a J option pane, right? So this is not JavaFX, this is Java Swing, a bit of an old technology, right? So, but the point is you display an input dialog and the user enters a string and they press OK and the string is returned to you. Okay, so, and then we check the password. So if the password evaluates to that, then we instantiate our real secret, and then we call the get secret of our real secret. But if the password is not correct, then we just tell the user that they don't have access, right? And then we return whatever result the user's password yields, right? So here, there's a comment that says, free advice, never store passwords in plain text, right? So you guys are second years. By the time you do informatics 2B, you understand what this means, right? But you should always store your passwords in an encrypted format, right? But you learn how to do that next semester. Okay, so and then in the client class, so the client only knows about the proxy secret, and then so they create the proxy, and then they call the get secret, right? So obviously the get secret is the one that's going to ask for the password, and it's going to check, you know, if the password is correct and return the actual secret. But if it's not correct, then it will just return the string, right? So so if the password was 12345, so this is actually wrong because this is 12345. So this should be corrected. But yeah, so let's assume it was 12345. Then it will return this is a secret. But for anything else, it will return you do not have access. Okay. Any questions regarding the proxy design pattern? Yeah, more straightforward than the adapted design pattern, right? Yeah, so let's move on to the last design pattern of the structural design patterns. Okay, so here we have something called the facade design pattern, right? So it's the same as like in human relations. If someone says you are putting up a facade, it means that you are putting up a false representation of who you really are, right? So that's the same idea of the design pattern, right? So it provides, but in this case, obviously, it's not just to fool the client, but it's to make the life easier for the client's program, right? So in this case, the facade design pattern provides a unified interface to a set of interfaces in a subsystem, right? So this is usually used when you have, for example, let's say like a lot of classes, right? And you want to interact with all of these classes. But in order to interact with all of these classes, you have to know how each and every class works, right? So you have to know that if I want to get information from this class, I have to call function A, but if I want to get information from this class, I have to call function B, and so forth, right? And which means that the more classes you have, the more you have to know, right? And that is usually not a great thing in programming because it doesn't guarantee future proofing, right? When you create something in programming, you want to be able to add to it later without the people that are using it to actually have to learn anything new, right? So if, for example, I'm using the sorting function of an array list, even if the people who keep developing and improving Java decide that there's a new algorithm for sorting data in an array list, I do not want to know about that, right? As long as I know that when I call sort in an array list, this will sort the data, right? That's all I care about, right? So in programming, you usually want to do that, right? So if you have a lot of classes, if you have a system where you are going to have to create a lot of classes, you want to create something that's called a facade, and a facade just provides a unified interface, right? That the client programs can interact with without having to know about the complexities of the underlying classes, right? So that's the basic idea behind the facade design pattern. So you use it when you want to provide a simple interface to a complex system. So it kind of provides a default view of a system, right? And also you want to use it when there's many dependencies between clients and the implementation classes of an abstraction. So this is when you have a lot of client programs, and then all of them have to know about, you know, all of the classes in your system, and then you have a tight coupling between your client and your other classes, right? You don't want that. So you want to decouple your client from your underlying classes so that they only have to interact with the facade. So this promotes system independence and portability. So you also use it if you want to layer your subsystems, right? So if, for example, when someone accesses this level of your subsystems, they interact with this interface. If they want to access the next level, then they interact with that interface. Sorry about that, and so on. But yeah, so this is how it looks. So you have a class called the facade, and it has the unified operation, right? And then you have subsystem A, which has its own operation, subsystem B, which has its other operation, subsystem C, which has its other operation, right? So the most important thing to note here is that there's no inheritance, right? So this is not the same as the other design patterns where, or rather you have implementation of an interface, right? So here you just interact with the class and the class just needs to know about the other classes, right? So the relationship here could be general association or it could be composition. It's really up to you, right? But there's no strict rule that there has to be an inheritance structure or a generalization structure where you're implementing an interface, right? So, so the facade knows the subsystem classes are responsible for a particular request, and it delegates client requests to the appropriate subsystem classes. And the subsystem classes simply implement, the functionality that they are responsible for, right? And they handle the work that's assigned by the facade object, and they have no knowledge of the facade, right? So that's also important to note here. So this class here doesn't know anything about that class, right? This class should know about all of these classes, right? But these classes do not have to know anything about that class, right? So that's important to understand because they have no reference to it, right? They don't store the class, they don't inherit from the class, and so forth. Okay, so let's look at the client, right? So the client makes use of the subsystem classes through the facade without having to know about the subsystem classes, right? So if you look at the client makes use of this class without having to know about these classes here. So let's look at an example of this as well. So let's say, for example, you are in a like you are on the websites of a travel agent, right? Let's say you're trying to travel, I don't know, like for holidays or something like that. And then, so the travel agent, for example, when you enter a destination, they'll show you the flight prices for that destination. They'll show you the car prices for that destination, and they'll show you the hotel prices for that destination, all in one screen, right, in one view. But you'll find that in the underlying system, you actually have three different classes, right? So you have a class for cars, you have a class for hotels, and you have a class for flights, right? But you as the client, you don't know about that, right? You only know about the travel agent class, right? So flights can be a subsystem class, cars can be a subsystem class, and hotels can be a subsystem class, right? So this is all you know about the travel agent facade, right? So this allows you to query all of the subsystem classes without having to do so for each class manually, right? So you don't have to know about the individual classes and how they work. So the client is the travel agent's program, which requests information about flights, cars, and hotels from the travel agent facade, right? So let's look at the classes. So this is the cars class. So this just stores car info, right? So it stores everything about cars. So this is a hire car, this is a taxi, this is a bus, this is a scooter, and the prices and the times. And then this returns the car info. And this stores flights info, so you can read through that. And this stores hotel info. And then here, then you have the travel agent facade, which knows about all of the different subsystems, right? So it knows about a car, it knows about a flight, and it knows about a hotel, right? So this is the unification part. So this is where all these subsystems are unified into one, right? So when you call this function here, get travel info, then the facade class will then get the car info, get the flights info, get the hotel info, and then it will create the return string, and then it will basically keep updating the string by taking the info for the car, taking the info for the flights, taking the info for the hotels, and then adding some message at the end, and then returning that string, right? So the client just knows about the one class, right? It knows about the facade class, and all it does is it simply instantiates that object, and it calls the get travel info, and that's the unified operation, right? Do you guys understand the logic behind this? Okay, so do we have, oh yeah, so we don't even have time anymore. So if you have questions, please email first, and then send questions to Discord, right? Remember, we don't always monitor Discord, but email. Yeah, thank you very much. Enjoy the rest of your evening.